Assalamu alaikum. Welcome to my YouTube channel. Today I am going to discuss how to implement fuzzy logic control in MATLAB Simulink software. Friends, in the whole fuzzy logic control series, following topics will be covered. Number 1. Difference between Boolean algebra and fuzzy logic theory. Number 2. Limitations of the PID control and need of fuzzy logic control. Number 3. Basic introduction of fuzzy logic control. Number 4. Mamdani fuzzy inference system. Number 5. Takagi-Sugino fuzzy inference system. Number 6. Fuzzy logic control implementation in MATLAB using GUI tool. Number 7. Fuzzy logic control implementation in Simulink. Friends, the subject fuzzy logic control has very large application in the different areas, especially in engineering sciences such as electrical engineering, mechanical engineering, civil engineering, electronics engineering, telecommunication engineering, control system engineering, chemical engineering, robotics, industrial process and control. And still there are many other fields where fuzzy logic control theory can be applied. Friends, due to this diverse nature of the fuzzy logic control, it is quite challenging to cover the whole theory of the fuzzy logic control with its implementation in MATLAB. It is because a lot of students read many books on the fuzzy logic control, however they still find difficulty to implement it in the MATLAB. Only few students become able to implement the fuzzy logic control in the MATLAB. However, those students still face many issues on how to implement that fuzzy logic control in particular engineering topic or problem. If you are suffering from any kind of the above issues, then this is the right platform for you. Here we will discuss all these issues. Now let's start. Friends, interestingly, the meaning of the word fuzzy itself is not clear or blurred, which means that fuzzy logic control can be applied to those complex systems successfully whose mathematical formulation is not clear or well defined. Now I am going to discuss the basic difference between Boolean algebra and fuzzy logic control theory. In Boolean algebra, there exist only two states, either true or false. It means either 0 or 1. Means either something is working 100% or not working at all. Either something is fully opened or fully closed. Friends, in our real life, some mechanism follow this principle. Such as, consider the example of an electric switch. It will always have two states, either on or off. Similarly, take the example of a circuit breaker. It will also have two states, either it is connected or disconnected. But there exist many cases where Boolean algebra is not applicable. In fact, in real life, majority of the cases don't follow the Boolean algebra or binary system. Such as, people are not always good or bad, black or white. They always have the gray shades. Means people are good in some things and they are not good in some other things. In real life, 0.1 or 0.2 is not 0. In fact, it has some value and weight. However, in Boolean algebra, 0.1 or 0.2 is considered as 0. Furthermore, in our daily lives, many mechanisms don't follow the Boolean algebra. Or we can say that Boolean algebra is not a suitable system to define them. Suppose, take the example of a person's height. A person cannot have only two states, either he is tall or he is short. He may have many states such as from short, shorter, shortest to tall, taller, tallest. Similarly, a room cannot have only two states, either cold or hot. It may have many states such as from hot, hotter, hottest to cold, colder and coldest. Similarly, an animal cannot have only two states, either slow or fast. The animal can run in many states such as from slow, slower, slowest to fast, faster and fastest. Similarly, a turbine valve cannot have only two states, either fully opened or fully closed. It may have many states such as from fully open, half open, quarter open to quarter kilos, half kilos, full kilos. Friends, it is clear from the above examples that in some application Boolean algebra can be successfully applied. However, in most of the cases and mechanisms, Boolean algebra is not a suitable system to clearly define them. It means that still another definition is required which should include all these states or conditions in order to define them properly and includes all their states. To address this issue, fuzzy logic approach is presented by Lutfi Asghar Zada in 1965. He was the first to publish the ideas of the fuzzy logic. Basically, fuzzy logic approach is the superset of the Boolean algebra. Fuzzy logic approach is more better method to deal with the real world. The main difference between Boolean algebra and fuzzy logic is that Boolean algebra deals with two states of 0 and 1 only, whereas fuzzy logic deals with all states from 0 to 1. I repeat again that Boolean algebra deals with two states of 0 and 1 only, whereas fuzzy logic deals with all the states from 0 to 1. Let's take the example of an animal speed again to further elaborate the difference between Boolean algebra and fuzzy logic approach. In Boolean algebra, an animal can have only two states, either slow means 0 or fast means 1. However, in fuzzy logic approach, its speed can be defined in many steps as below, namely slow, slower, slowest, fast, faster and fastest. Even we can increase many other states if needed. Friends, I think now you are clear what is the difference between Boolean algebra and fuzzy logic approach. And now you are clear why fuzzy logic approach is needed in the real life. Now I am going to discuss the limitation of PID controller and the need of fuzzy logic control. Friends, to address this issue, I am going to discuss with you an example of load frequency control in power system. Consider the figure which shows the transfer function model of the power system. We know that commonly governor is used to control the speed of the turbine in order to keep the frequency of the system constant. Whenever load is suddenly increased, the power system frequency is decreased. In this situation, governor sends this decrease in speed and sends the signal to turbine to open its valve in order to increase the power generation. When generated power and increased load demands are equal, the system frequency comes to the stable value of 50 or 60 Hz. Similarly, whenever load is suddenly decreased, the system frequency suffers from overshoot. Governor senses again this increase in frequency and sends the signal to turbine to close its valve to some extent in order to reduce the power generation. Now again, when the generated power and the reduced load demand are equal, system frequency will come again to stable value of 50 or 60 Hz. Friends, in the past, mechanical hydraulic governors were used to control the speed and frequency. Mechanical hydraulic governors have the limitation of slower response due to the fact that it contains the mechanical components such as dashpot and piston in the mechanism. These rotating components have their own inertia and takes lot of time to respond in case of increase or decrease in load. Due to this slower response of mechanical hydraulic governors, system frequency takes lot of time to stable. In order to make the response faster, electro-hydraulic PID based governors or controllers are employed. Electro-hydraulic PID based governor or controller replaces the mechanical components of dashpot and piston with electrical components. As these electrical components are static in nature, therefore they don't have inertia, due to which their response time is faster as compared to the mechanical hydraulic governor. Furthermore, PID controller provides robust, satisfactory control of frequency by changing the parameters of P, I and D gain. Friends, as we know that the load demand in power system is variable in nature. In fact, the load demand is continuously changing throughout the day. In the morning, load demand is different. In the afternoon, the load demand may increase. In the night, the load demand may decrease. It means that power system is subjected to continuous load variation. On the other hand, PID controllers has the limitation that its parameter cannot be tuned online for continuous load variations. Due to this, PID controller cannot provide the best optimal response for all load conditions. It means that we have to do some compromise in such a way that we will test the performance of the PID controller for all the cases with different parameters, and we will observe at what single value of P, I and D its response for all conditions is satisfactory. We will then take those values and used in the PID controller, which means that PID will provide compromised or satisfactory response for all the conditions. However, it will not provide the best optimal response for all the conditions. Friends, on the other hand, fuzzy logic control has the ability that if you define the rules for all the conditions separately and properly, then it will provide the best response for each conditions every time. Which means that fuzzy logic control provides the optimal or best response as compared to the PID controller. To conclude this discussion, PID controller has the limitation of parameter tuning, and it cannot change its parameters simultaneously for all loading conditions. Therefore, PID controller provides compromised or satisfactory response of the system, and it failed to provide the best optimal response for all the operating conditions. Whereas fuzzy logic control has the ability that it can provide best response simultaneously for all the operating conditions. Friends, at this stage, one may wonder or question may arise in his or her mind that does fuzzy logic control has any limitations or not? The answer to this question is that yes, no one is free from limitations. So does the fuzzy logic control. Fuzzy logic control has the limitations too. However, I am not going to discuss it now due to the time limitations. I will discuss the basic working principle and its method in the next video. In that video, I will cover the limitation of fuzzy logic controller too. Friends, in this video, I have basically discussed the need of the fuzzy logic control. I have discussed the difference between the Boolean algebra and fuzzy logic control approach. Furthermore, I have discussed the limitation of the PID controller, and I have discussed how fuzzy logic controller approach can address these limitations. Friends, kindly stay connected with me. I will teach you the whole fuzzy logic implementation in MATLAB Simulink. However, for this purpose, I would like to request all of you that kindly show some patience. It is because to fully understand the fuzzy logic implementation in MATLAB for a power system problem, we must be clear about its basic terminology. That's why I have started with the basics of the fuzzy logic approach. Hopefully, I will complete the fuzzy logic implementation in MATLAB within the 3 parts. That's all for today's tutorial. If you like it, then don't forget to like my video, subscribe my channel and share this with all your friends so that they may also get benefit from this video. Thank you very much.